It's me, Mario Maker. Hello everyone, let's start! Yeah!
Games are bigger and more complex now than they've ever been.
Xbox One X, the most powerful console ever made.
It's 4 times more powerful than the Xbox One X.
Ooh.
The massive local storage.
6 teraflop GPU.
With HDR and surround sound.
Up to 20% faster per frame.
Up to
Oh my gosh, the technology kept improving, and then there's something called PS5! PlayStation 5.
120 frames per
More
second.
immersion,
4K
more
resolution, 8 million
exploration,
pixel
more
textures,
detail.
high dynamic
Gigabytes
range,
of high-speed
wide
unified
color
memory.
Open world video game.
But what if I told you that this is the world's most complex game?
Really? Really? Oh wow, notice the desk, right? The desk, there's Diet Coke, and then there's FNAF. Ah! Oh! Oh!
Hello, Internet! Welcome
Ruin your childhood since 2011.
to Game Theory, the shell jump of YouTube shows.
Hello! Hello, game theorists! The shell jump of YouTube. True. If you really think about it, that's kind of true.
Seriously, we are exactly like a shell jump. Takes a little bit of work to fully get used to, but once you get it, you feel awesome and you look super stylish when you do it. And by do it, I mean talk about theories on your favorite video games. Impress your friends with your knowledge. Probably annoy them a little bit, but you know what? They're annoyed because they thought what you had to offer was pretty cool. At least, I can only assume that's why they're annoyed.
Well, we assume.
Anyway, speaking of shell jumps, that is a not-so-elegant segue to the fact that Super Mario Maker 2 is releasing, like, now. I cannot tell...
No, not now, right? This video came out 2 years ago, back in 2019, so... yeah, but still, awesome.
you how excited I am for this game. Infinite Mario levels at whatever difficulty I want, whenever and wherever I want on the Switch. Take my money, Nintendo, for the last time. You fools! You've given me the Mario game to end all Mario games. Teach a man to fish, he eats forever. Give a man Mario Maker on a portable console, and he plays for a lifetime while only paying for the game once.
Wow! From MatPat.
In a year full of, well, in a year that's devoid of really big releases, that doesn't have a lot going for it.
Ooh, don't say that, 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 don't say that. 2020. Yeah. 我不追走
Mario Maker is still a shining beacon of hope, not just for me as a gamer, but for literally every other gaming YouTuber whose thumbnails don't have #1 Victory Royale plastered in the corner, or Ninja's face somewhere. Now, the last time we talked about Mario Maker, we discovered just how gigantic of a game this is. The number of possible levels in Mario Maker is so big that it can barely fit on screen. A number so large, it was more than the number of atoms in the known universe.
To the point in which Google just says infinity.
A number so massive we had to give it its own name, the Marioplex. But instead of doing the same calculations to see how much bigger this new game is, I actually wanted to ask a different question this time. Not how big Super Mario Maker is, but rather how complex it is. Now, that might seem like I'm just splitting hairs, but think
Big or complex?
about it this way. I could throw out a math equation that combines really big numbers, or mixes in some exponents, but even someone with basic math skills could solve it with the basic principles of addition and multiplication. Adding in layers of parentheses within parentheses in that math equation, though, addition and then an exponent, for instance, now that makes the problem more complex.
Increase the complexity of it.
And complexity matters because, in some ways, it's a measure of how smart a game is. And when you actually look at Super Mario Maker that way, not only is it one of the biggest games of all time, but it's also one of the smartest games of all time.
Wow! The smarter games of all time! Gosh. Oh my gosh.
And to show that, we actually built a computer inside of Mario Maker. You see, the true measure of a game's complexity isn't just in presenting you with problems to solve, it's in the game's ability to solve the problems on its own. Video games are, at their core, just computer programs, right? Programs built to execute code that takes you on grand adventures. But when you're suddenly able to build an actual working, functional computer inside of a video game, well, now you've unlocked something that's a lot more significant. You've created something that can run any algorithm, or any set of algorithms. In a theoretical sense, it can run any program that your computer can run, including other video games. Now, obviously, there are massive restraints to this, but in essence, you've created a machine that can run the game within the game itself. Minecraft is probably the best example of this.
Oh my god, it can be like Inception! A game inside a game inside a game.
Or some creators like Requag have made full-on Game Boy emulators that play Pokemon Red within the world of the game. Now, Mario Maker isn't able to be that complex, but the basic tools to do that exact same thing are there, which is not that far off. First off, if we're claiming that Mario Maker allows you to actually construct a computer within the realm of the game, we need to understand, at its most basic level, what exactly a computer is. The man credited with inventing the computer is Alan Turing. Remember the imitation game from a few years ago starring Dr. Strange? Well,
Starring Doctor Strange, or you can think of him as Sherlock Holmes. Benedict Cumberbatch. You know, Benedict Cumberbatch. He's a very handsome individual actually, if you think about it. And also, I'm going to say this, penguin, penglings, penguins. Chad, do you understand a joke? If you're watching this video, do you understand the joke?
if not, it's a great movie that you should totally watch that tells the story of Alan Turing, working to break the Germans' unbreakable Enigma code in 1942, smack dab in the middle of World War II. What that movie doesn't show, though, about Alan Turing is that he'd already made history 6 years prior, back in 1936, by laying the groundwork for the way that all modern computers would work from there on out.
Turning machine. Alan Turing machine.
Basically, he described a theoretical machine that could solve any problem, as long as that problem was described by simple instructions coded onto a paper tape, with cells that could be in one of two states, either filled in with a symbol or a blank square. Nowadays, instead of a paper tape and blank squares, we actually have computer memory and binary code. You ever wonder why binary is the most basic level a computer operates on? It all dates back to Alan Turing. Zeros and ones are just the modern equivalent of empty squares and filled in circles from 1936. So, in its most basic form, a Turing machine, aka the most basic form of computer, needs to be able to do 4 different things. 1. Store values in some sort of memory. 2. Read and write values from and onto the memory. 3. Keep track of where it is in the memory. And 4. Follow an algorithm, which are basically the instructions that tell it what to do depending on what state it's in and the value that it's seeing from the memory. And sure, over time, computers have gotten faster, and we've developed
Faster, better, more improved with the complexity involved.
things like programming languages that make it easier to communicate with them, but at their core,
Python, JavaScript, C++.
or a computer from 2019 is still performing the same basic operations as one from 1984, or heck, one from the 1940s, if you want to go that far back. So knowing all of this, how do you make a computer inside of a video game, like Minecraft or Mario Maker? And how complex is this thing able to get? Well, in Minecraft, it's actually a bit simpler to do. You have switches and torches and redstone, and from those rudimentary tools, you're able to build everything from game emulators to full-on working video phones. Mario Maker is going to be a lot more limited based on the more streamlined gameplay and tool set, but it too can show off its functionality as a simple Turing machine by running, drumroll please, Basic Edition. Ladies and gentlemen, I present to you the Mario Maker Calculator.
Wait, Mario calculator, but it only have 0, 1, 2, 3, 4, 5, 6, 7. Plus, dot, and 0. Where is the minus? Where is 8, 9, 10? Huh. Why? Where is it? Where is multiplication? Where is division?
In this level, we're able to add together any two numbers between 0 and 7, and after a bit of auto-scroll, display the final result. Is your mind sufficiently blown? No? Then just wait, because once you know how and why this thing works, you're gonna really appreciate how crazy builds can get inside Mario Maker, and how it's gonna reach whole new levels in Mario Maker 2. So this level, titled the Cluttered Chaos-Calculator, was originally designed by user Helgefan. Using his model, we actually rebuilt the whole thing piece by piece, kinda like how you follow the instructions for a Lego set, all in our attempt to understand how a computer like this would operate, as well as just how far it's able to be pushed.
So, so understand it from the base from and transfer it into simple 0 and 1 and 0. Oh, fun fact, a joke, alright? There are only 10 types of people in the world. Those who understand binary and those who doesn't. Get it? Because 10 is like 1, 0, 10, and 1, 0 is two different. It's like yes and no. That means there's people who understand it, yes, 1, everyone who doesn't understand binary, no, 2, a 0, so 1 and 0. Get it? Get it? Anyways, let's continue.
The first and most important question with a build like this is, how do you recreate binary in a game like Mario Maker?
True, how do you recreate binary in Mario Maker? That's important.
In Minecraft, like I said, it's actually a lot easier. Torches can act as your 1s and 0s. If they're lit, they're a 1. If they're extinguished, they're a 0. Easy, kinda. I mean, it's not rocket science, but it is computer science through the realm of a video game. It's a couple layers removed, but still. Anyway, what is our binary equivalent in Mario Maker? One word, shells. Just like a filled-in box in the original Turing machines was a 1, and the blank box was a 0, the presence of a shell is gonna be our 1, and the absence of the shell is going to be a 0. The shell is actually the carrier of data in our Mario Maker computer. So a sequence like this one that you see on screen right here, in which 2 shells are blocked and 1 gets through, well, that would read as 1, 0, 0 in binary. And this gets to our first major limitation of Mario Maker as a computer. You might be wondering why the calculator is limited to only the numbers 0 through 7.
Oh, because 1111 is...
Well, you've probably heard of bits, right? Well, a bit is the smallest possible piece of data, a digit that can only represent one of 2 possible states, those 2 possible states being a 0 and a 1. In a normal base 10 counting system with a single digit, you can count all the way up to 9, and with the second digit, you can count all the way up to 99. 3 digits let you count as high as 999, pretty straightforward, it makes sense. However, if each bit can only store 2 possible values, a 0 or a 1, like in binary, then our counting system is going to look a lot different. It starts...
There's the base 10, and then there's binary.
That's 0. That's just 0. And it goes to 1. So
oh, fun fact, there's also a base 12 used by civilizations in the olden days. Some civilizations, they use 1 to 12.
So far, so good. Pretty easy, right? But where do you go from there? You've run out of space. There is only 2 possibilities for that first digit. So you need to introduce a second bit to store more data. By introducing a second bit, we can now hold 2 more numbers. 1, 0 is now 2, and 1, 1 is 3. But once again, we've reached a limit of space, meaning that now we have to introduce a third bit. 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 0 is 6, 1, 1, 1, 7. If we wanted to get up to 8, we would need to add yet another bit. 1, 0, 0, 0. The issue here is each of those digits takes up more and more memory. 1 more bit of memory, to be precise. Going from 7 to 8 might seem like it's a small deal, but for a simple computer like the one we're making in Mario Maker, that increases the memory storage space from 3 bits to 4. It's a whopping 33% increase in the amount of data that we need to store, and a massive amount of additional level that needs to be created in order to account for that additional memory. That's why, on the first screen, you're able to input any number from 0 through 7. That's as high as you can count in 3 bits. So let's say, for example, we select 4. According to our binary chart, 4 equals 1, 0, 0. Shell, no shell, no shell. And just like that, we see these 2 bounce off the P block with only the first one getting through. By converting our numerical number 4 into 1s and 0s, or in Mario Maker language, shells and no shells,
Shells and no
Now
shells.
have it stored in a form that our Mario Maker computer can actually do things with. And that means that it's now time for the actual math, which is just like back in elementary school. You start in the ones place, and then you work our way to the other digits from right to left. If we follow the path of the shells, you'll see that both A1 and A2 shells are being taken to a section labeled HA, H-A. That stands for half adder, which takes our
adder.
first two bits on the far right and adds them together. If the sum is too large to fit into a single bit, then that tells us that we need to carry that 1 over into the next place. It's just like adding when you add 5 and 5. You get 10, but you have to carry that 1 over into the next digit. In binary, when you add 1 and 1, you're going to have to carry that 1 over into the next digit. You'll notice that every other shell here is ending up in a fa. Full adder. The difference here, and what makes it full instead of just being half, is that instead of just adding 2 bits of data, full adders are now actually adding 3. The 2 shells that we input at the beginning, plus the possible carryover bit coming from that half adder above. If that sum is now too large to fit into the second bit, then it has to carry over into the third bit, and the adders below that, and so on and so on. Remember, though, that our final answer could be as high as 14. That's a 4-bit number there, my friends, 1110, and as such, we have to make sure that we add an additional shell along the way. That's line D that you see right here. So we have our input, we have our addition, and that's basically it. We have our answer, and the rest of it is just a matter of destroying ice blocks to display it, which, as you can tell, is a lot easier said than done. Yeah, simply writing out a number like this requires a lot of different functions. There is one final snag, though, that we run into when using turtle shells as our method of storing data. Mario Maker only keeps track of objects that it considers to be relevant, i.e., it only keeps track of shells and enemies if Mario is close enough for them to matter to him as the player. In an ordinary Mario Maker level, this makes total sense. If a shell goes way off to the other side of the map, it's basically irrelevant, and it makes sense to despawn it so the game can save on processing power.
That is true. That is true. I didn't think of that actually. That's very interesting idea.
That becomes a problem for our calculator, though, because all of those shells are relevant. Sure, they may not be touching Mario, but they're carrying valuable data that we need for our calculations. This is exactly why this level winds up being an auto-scroller. Mario has to move with the shells to prevent them from despawning. Without knowing how all of this works, it would seem like this is just to show off the fancy mechanics of shells bouncing around inside of a calculator, or just as a means to pad out its length, but in truth, Mario is taken on a grand adventure, A, because it takes this long to perform the operation, and B,
That means, technically speaking, right, the loading screen is the entire sequence. Takes quite a while, isn't it? Can be shortened, right? Room for improvements.
because without Mario, these data shells would be considered irrelevant and just disappear from the map. All of this time and meticulous attention to do something a first grader could do. At the start of the video, we established that a Turing machine can do anything a computer can do. It's just that an analog Turing machine would process things much, much slower than your typical computer nowadays. See, a basic calculation like adding 2 plus 3 equals 5 actually requires a Turing machine to take 5 steps. As such, you can imagine that a more complex problem, like multiply these two numbers together, or something a little bit more ambitious, create the data inputs needed for my monitor to display this exact configuration of 2 million pixels and do that 60 times every second, is gonna require just a few.
AKA playing a video. Oh wow, let me see again. How do you explain it?
Or something a little bit more ambitious, create the data inputs needed for my monitor to display this exact.
Create the data inputs needed for my monitor to display this exact configuration.
Configuration of 2 million pixels and do that 60 times every.
Or this exact configuration of 2 million pixels and do that 60 times per second.
Every second is gonna require.
AKA play a video game.
Just a few more steps. Modern computers are capable of processing billions of instructions every second. Our Mario Maker Turing machine is going to be just a wee bit slower than that, since our instructions are carried out by moving shells. Even if we're performing the most basic calculations, each step in that process is gonna take a couple of seconds. So let's do the obvious thing. Compare our Mario Maker computer with a modern 2019 computer. See how they stack up. A typical modern computer built in the last 5 years is gonna average about about 200 billion instructions per second. Our
Average
Mario
out.
Maker equivalent would take 12,680 years to do what a modern computer can execute in 1 second. Try to match 16 seconds of operation from a computer, and the Mario Maker machine is going to be taking over 200,000 years. That is longer than humans have walked the Earth. That is 16 seconds of processing power from one modern computer over 200,000 years for Mario Maker to accomplish. Needless to say, while a Mario Maker computer is theoretically possible, you're not going to be using it for much more than basic arithmetic if you want to get an answer within your lifetime, or your child's lifetime, or your grandchild's 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 lifetime, or heck, you'll barely get an answer for your 16 seconds worth of modern computing within the time it takes for the universe to die from heat death.
Wow, die from heat death. That is how long it would take. A bit too long, right?
And of course, all of this is assuming that Mario Maker has infinite processing power, which it doesn't. It would actually take a lot less time than that for your Mario Maker computer to just run out of space. While our Mario Maker storage is measured in bits, a computer's storage is measured in gigabits, with each gigabit representing 8 billion bits, literally 2 billion times as much data as the final 4-digit number produced at the end of our very basic adding function. So yeah, I would say that Mario Maker has a few limitations, but then again, so does every computer. Every computer, even the really, really fast ones with tons and tons of storage, have physical and finite limitations. So no machine truly counts as Turing complete, in the sense of actually being able to perform any operation, because you could always throw something at it that would require more space and speed than it can muster. But if you remove that limitation, any computer capable of performing those basic functions, no matter how slowly it does it, can theoretically be Turing complete, including one that was made inside of Mario Maker, thereby making it one of the world's most complex games. But hey, that's just a theory. A game theory. Thanks for watching.
Thank you so much. Now that's interesting. We get to know so much about computer science, programming, and think about it. I just really love it. Thank you so much for watching this video. If you do like this video, please remember to like, share, subscribe to my channel, and comment down below if you find any of us. Do remember to follow my channel as well. Thank you so much, and I'll see you next time. Thank you. But hey, that's just a theory, a game theory. Thanks for watching. Thank you so much. The video that they just created came from the YouTube channel The Game Theorists. Their videos are awesome, and do check them out. Do show support and appreciation and watch more of their videos. Their videos are amazing. This video came out in the year 2019, so I think it's around 2 years ago, and yeah, thank you so much for watching this video. I also really like the fact that they have so much nerdy stuff, geeky stuff, and just a lot of educational programming stuff. Oh my gosh, what am I doing? Thank you so much for all of your support. Thank you.